Hi, I'm Ranger, and this week we're going to be doing a problem involving potential energy functions. And so, in this problem, we're given a potential energy function u that depends on a position x, and this is for a particle just moving back and forth in the x direction. And this u function looks like ax squared plus b. And what they tell you is, at x equals some value x naught, the particle is at rest. And so our job is to find the kinetic energy when x equals 0. So here's how we're going to do that. We're going to make the assumption, and this is always a safe assumption in a particle in 1D with a potential case, that we're going to make the assumption that this potential is the only potential acting on the object. So there's no gravitation or springs or anything around. This completely describes the potential energy. And then we also know that for just a particle in one dimension, in just under this potential, the only sort of other type of energy that will be involved is some sort of kinetic translational energy. So with that in mind, we can write out the work energy theorem. So work equals change in energy. And if I say my system is just going to be everything, it's going to be this potential, whatever's causing it, and the particle, then I know that that's going to reduce down to just change in kinetic energy plus change in potential energy. So, with that in mind, I know, since I just said the system is everything, and I'll write that just to be sure, system, all, so everything, I know that the work done has to be 0 because there can be no external force if everything is in the system. So that'll go to 0. And as a result, I get 0 equals delta k plus delta u. Now if that's the case, I'm going to write this out a little bit more thoroughly. Delta k is really just k final minus k initial. Delta u is just u final minus u initial. And here's what I can do. I can say, I'll choose an initial time that I know a lot about, and I'll choose a final time that I want to know about. And so my initial time is going to be, or really an initial location, is going to be x naught when this thing is at rest, because at that point I know v equals 0, and so I know 1/2 mv squared equals 0, and so I know kinetic energy equals 0. So I'm going to say at the initial time, u at the initial time is just going to be me plugging in x naught to my u function. So a x naught squared plus b. I know my kinetic energy at the initial time is going to just be 0. And the final time is the time that I want to know about. So I'm going to choose the time that I'm asked about, x equals 0, or the position I'm asked about, x equals 0. So my u at the final time, so for f, u final equals 0 plugged into here, which will give me b. And then k final is what I'm looking for, so I'm going to leave that as a question mark. And at this point, I can just plug up into this equation right here. I can say 0 is for k initial, k final is the variable I'm solving for, plus ax naught squared plus b minus b. And if I do that, I'll end up with kf minus 0 plus u plus a b minus an ax naught squared minus another b. So the b's will cancel and I'll get a minus a x naught squared. And so kinetic energy at the final time is just a x naught squared. So that's all we have to do.